I'm Margaret Chiosi for AT&T, and I've been leading the Cloud SDN effort at the MEF, along with Ralph Santatora from Fujitsu. The goal of this talk today is to talk about the MEF carrier Ethernet relationship with SDN. But before we can define that relationship, I'd like to define what SDN is. So I took two definitions I found in the industry, which I think are effective in describing what SDN is. The first is, it creates an intelligent network that is open, programmable, and application aware. Basically, the vision is the network is transformed into a more effective business enabler, basically making money faster. A second one is more technical, where it enables applications to request and manipulate services provided by the network, and it allows the network to expose the network state back to the app. There are actually two implementations going on in the industry today. One is the proprietary router market, where the hardware and software are provided by one vendor. This is analogous to the server market, where IBM in the 70s provided the hardware and software for that market. Not only the software for our operating system, the tools, the database, as well as the applications. The second implementation is this ONF OpenFlow standard, where the control and the data plane are separate, and there's a standard interface defined between them. The controller is open source software that can be provided by one vendor. The data plane is provided by another vendor on merchant silicon versus custom silicon by a different vendor. The analogy in the server market, again, is the Unix environment or the Linux, which is open source operating system based on Intel hardware. The MEF focus on Ethernet services in the WAN, so the definitions surrounding that. The ONF SDN focuses on implementing the network equipment for these services, so the how to implement the network equipment. So getting back to the relationship of MEF to SDN, going back to the original definition of open, programmable, and application aware. The MEF Technical Committee is focused on the APIs needed to dynamically configure, monitor, and manage Ethernet services more easily. There are actually about 3 use cases that the MEF is focused on to flush out these requirements in the SDN world. The first is resource bursting, or cloud bursting, that is stated in the cloud market. This is where you can elastically grow the bandwidth needed for the apps, collecting billing information or statistics for the billing information, performance monitoring, capacity planning, and other functions. This allows customers to dynamically request and pay for resources when they need it, versus today statically, and in some sense statically defining peak usage, which is not used all the time. Second one is network slicing, where a customer is able to create a network that appears to be privately theirs. They can identify the routers or switches, where to put them, the trunks between them, the bandwidth between them, and even the type of protocols running on the network, whether it's BGP, Ethernet, MPLS, etc. And this would be done on a shared hardware platform with other customer networks. And then the final area is traffic engineering, where you can run the network much hotter than today. Today you might be running the network at 60%, allowing for peak handling of traffic, bursting of traffic, as well as extra capacity for failures in the network. So by focusing on traffic engineering in this new space, you can run the network maybe at 90, 95% versus the 60% that happens today. In summary, the MEF focuses on the what of defining Ethernet services in the WAN, while ONF SDN focuses on the how the network equipment should be developed. Thank you very much. This is Margaret Chiosi from AT&T.